Hey guys, welcome to Homework Help for Year 7, Term 3, Week 8. On page 25, we're doing Set 7. Question 1. Study the nets illustrated below. Which solid do you think that each net could be folded to form? Copy each net onto a rectangular grid paper, cut out each net and fold it to form a solid. Were your answers correct? Okay, so we're not going to do this part where we have to cut it out the solid and create the shape. What we're going to do is look at the picture and imagine, using your imagination to fold it, and then we're going to write the solid that forms once we fold all the sides up. So for question A and B, just do that, write the answers down there somewhere. I'm not going to give you the answers, these are pretty simple. Question 2. Name the solids that have the following nets. Okay, so again, we just have to name the solids. Using your imagination, just fold them up and write what you think the solid that is created from these nets. Question 3. Choose the correct net A, B, C or D for each solid below and state its name in each case. Okay, so just write down what you think the name of the solids are for these ones. Now, to name this solid, we know this is either a prism or a pyramid. A pyramid has the apex, so all the vertices join to one point, like this. Okay, so obviously B is a pyramid. Now let's look at A. So what kind of, we know it's a prism, what kind of prism is it? So let's look at the shape. Well, the shape that is from the base. Just count how many sides there are. 1, 2, 3, 4, 5, 6. It's a 6-sided shape, which for 6-sided shape is called a hexagon. So we call this hexagonal. Prism. And we know this one's something pyramid, so let's count the base, the size of the base. 1, 2, 3, 4, 5. It's got 5 sides, so we know 5 side is usually called pentagon, so this is pentagonal pyramid. I'll leave the rest to you. Okay, next page. Again, so now this is the same thing, just name the nets and imagine if you fold all the sides up, what solid would you get? Question 4. Name the solid that has this net. Now, this net has what kind of triangle this is? Well, all the sides are equal, so therefore this is an equilateral triangle. When you fold this up, you're gonna get a shape that's it's gonna be a triangular pyramid, right? If you fold it up, so you're gonna get triangular pyramid. However, because this shape, all the triangles are congruent to each other. It means congruent, by the way, means identical. So this shape here is identical to this shape, okay? And they're all the same. So therefore, since they're all congruent to each other, there's a special name for this. This is called a tetrahedron. And it's one of the Platonic shapes. There's other types like a cube. A cube also has all of its faces. They're exactly the same. They're all congruent. Okay, whoops, I just drew it wrong, but whatever. Okay, next one, question. So this one is called tetrahedron. That's the answer for that one. Name the solid there. State the number of faces, vertices, and edges of the solid. Okay, so number of faces, you got so you can write faces equal to whatever, vertices equal to, and edges equal to, so on. Is the number of intervals in the net equal to the number of edges in the solid? Okay, the number of intervals, what it means is this. This is one interval here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So you got 9 intervals. Let me say, is the number of interval in the net equal to the number of edges? How many edges do we have? When you fold this shape together, how many edges you're gonna get a shape that looks like this. Okay, you got 1, 2, the back one is 3, 4, 5, and 6. You're gonna get 6 edges. 6 edges, but you got 9 intervals. So no, they're not equal to each other. And it says explain. The reason is because when we fold it, for example, let me just rub this out. When we fold this shape to form the solid, this interval here, and let's say which other one would it be? Probably this one. They're going to join together to become one edge. Okay, even though there's 2 intervals, it's going to be 1 edge. So when you join them together, all the intervals actually will combine together. So there's less edges than intervals. Okay, next one. Name the solid that has this net. Okay, so when you fold this net together, you're going to get something that looks like this. Hopefully I draw this accurately, something like that. And it says state the name. Okay, name. Now it says state the name of this solid. This is called trapezoid prism. And B, state the number of faces, vertices, and edge. You can do that on your own for question B. Question 6, draw 3 different nets for a cube. Okay. Well, one of them is going to look like this. This is the most famous one. Okay. And just think of 2 more. If you have any problems, you can look it up on Google and see what the answer is there. There should be 11 types altogether. 11 types of nets for cubes. Draw 2 different nets for a triangular prism. Okay, you can do that on your own. Draw 2 different types of net for a square pyramid. That's not too hard as well. Draw 1 net for octagonal. Okay, so you can do all those. Question 7. Draw the net of a cylinder which is closed. Okay, so this is really simple here. This is a closed. And this one is going to be like this. And like this. And open would just be like this. Something like this. Okay. Done. Next page. Question 8. Which open shape could be formed by joining the edges AO and AB? So if we were to join these 2 edges together, what kind of shape will we get? Now this is going to require a bit of imagination. So if you join them together, this will be like the point where everything connects. Okay, and you have like a circle. So it's going to be something like this. This is the point O right there. And imagine if there's a line. This is A and B is now joined together to become this point here. Okay. So what's says which open shape? So what's this shape called? Obviously a cone. Question 9. This is a net of a cube. When the sides are folded up and joined, which faces would be opposite each other? Okay, so you have to use your imagination and figure out which. Okay, I'll just give you one of them. So let's say if I fold it, this and this will join together. So that means that, imagine if I draw, this will be A here. And if I fold this D up like this, then D would be here, isn't it? And then if I fold this one, this C upwards, C would be here. And then, let me see, what else? Okay, and then let me see, F would go on the very top, and then E would go to the side. So you have, then you can just write all the so A and D would be one of them. These are the opposite, and just write the other two. Okay, question 10. Which of the following could not be the net of a triangular prism? Triangular prism. Okay. So we have to, let me see. So you have to imagine folding this, all of these shapes together, and see which one can, but then identify which one cannot be, and circle that one. There might be more than one answer. Question 11. Draw as many different net as you can for a cube. There's at least 9, so there's 11. Okay. Just, I don't know, draw a few, whatever, that's fine. Now remember that rotating or reflecting, turning over the net does not produce a different net. So for example, we might have a net that looks like this. Okay, if you turn this upside down, this is the same net. It's just been rotated. It's not a different type of net. Okay, so another different type of net might be something like this. I think what is 1, 2, 3, 4, 5, 6. Can I fold this into a cube? Yes, something like that. So these are two different types of net, okay, but these are the same. So just try and draw as many as you can. Okay, draw as many different net as you can for tetrahedron. Now tetrahedron only has two nets, two possible nets. So you can try and draw them. The first net would look something like this. And the second net will look something like this. 1, 2, 3, 4. 1, 2, 3, 4. Yes, that's right. Something like that. So those are the only two types. Now, question 13. Copy these net into one. No, don't do this question. I crossed it out on purpose, so you can skip that question. Okay, that's the end of that one.